All right, so I wanted to throw this up here on YouTube for you guys real quick. That way you could kind of get an idea of how to start assignment 3. It all comes back to one of the videos that I wanted you guys to watch. It was this guy, I don't know what was his name, Flipping Physics apparently. His video on wave superposition. Again, this is in chapter 14, where we talk about what happens when waves, literally just being disturbances in a medium, it's energy traveling through, not individual particles. But what happens when they occupy the same space at the same time? Remember, they're not colliding and bouncing off of one another, they just happen to overlap. And his video does a pretty good job of walking you through what that would look like visually. So you'll see here the two waves approaching each other, similar to what you're going to see in assignment 3. And then when the two waves would overlap, you'll notice that the amplitude dramatically increases. This is constructive interference as opposed to destructive. If one of these had a positive amplitude and the other one was a negative amplitude, they would have canceled each other out. But that's what you guys to be doing for assignment number 3. So if we take a look back at assignment number 3, it looks something like this. You've got all 4 of them. I'm not going to do the last 2. I want you guys to just practice them again. This is just for practice. See what happens when they overlap. But what you should notice is that with pulse A being colored red and pulse B being colored blue, each one of these moving 2 squares per second. So wave A in the next second, down here at second number 1, will have moved the front end of its crest over 2 boxes and the back end of its crest over 2 boxes, and that's where I drew its new position. And you'll see I did the same thing with B, and when we get to where they overlap and occupy the same space at the same time, you should recognize that they both should be, negative versus positive, one on top of the other, but the green line that we're going to be drawing is going to represent the superposition, the location of what that slinky in this guy's video would look like, because he did a positive negative amplitude one right here. We'll show you what it looks like when the two of them actually collide. So go back right here. You'll notice that you get really, really close to zero amplitude as they overlap one another, and that's what you should have noticed here. So while the two waves themselves still exist independently, and you still see the red and you still see the blue above and below, what you would actually see in you is that green line. This is going to be really important when we talk about sound in terms of noise canceling headphones or even light with diffraction, a few concepts we'll be getting to a little bit later on. But the green line should be perfectly flat, perfectly horizontal, because those two cancel each other out. And then afterwards, once they're no longer overlapping each other, you'll notice they continue moving on in their own independent directions as if the red wave had never encountered the blue wave. What you'll notice here in number 2 is not destructive interference like we saw in number 1, but it's constructive interference. Both of these have positive amplitudes. When the two waves overlap with one another, you'll notice that they actually wind up doubling each other's amplitude. That's the concept I want you guys to get. This is something that we'll refer to as resonance. That's why standing waves are important. It literally describes how all musical instruments work, how amplifiers for guitars or any other electronic instruments work. It's going to be the foundation for all of that. So if we're able to just at this point recognize that when the two waves are occupy the same space at the same time with opposite amplitudes, they cancel if they happen to have the exact same value, in this case an amplitude of 2 boxes, they perfectly cancel. Sometimes they don't, and that's fine. If the red one had an amplitude of 3 boxes and the blue one had an amplitude still of -2, the resulting wave would have an amplitude of +1. So they cancel just like normal mathematics, +3 minus -2 or plus -2. And then over here, where they constructively interfere, they actually build on one another. So you get a +2 and a +2, and your new resulting amplitude is +4. And it doubles its amplitude in that case. Had red again been 3 and blue been a +2, your resulting amplitude would be 5 or something like that. And then again, as they continue on, you'll notice that they continue acting as though they had never encountered one another at all. I want you guys to do the same stuff for the final 2. I'll have the answer key for this posted up in our folders for Unit 12 by the end of the night tonight. You guys can look it over. Again, this isn't due till Friday, but make sure you drop it off or deposit it, upload it in the assignment on Edmodo. See you guys later.